Okay. The only thing that's going to change between what we learned in 8.11 is now we're going to revolve around different lines instead of an axis. So recall that if you're having a washer, that's when we're integrating, guys, and there's a gap. So all of our cross sections really have holes. So this is why we have to do the process that we're doing now. So the volume of a solid using the washer method, recall, is we're going to put the pi on the outside. And it's going to be the integral from a to b of capital R of x squared minus little r of x squared with respect to x. So I've talked to you guys about this in the last couple weeks, and then grading your exams and grading your quizzes. I will for sure take off points on the chapter 8 test if you guys don't put this is called your differential. Please do not forget this when you're integrating. It's not optional. And this whole chapter, guys, aren't we doing integrals? So I need to see an integral if the process requires an integral. Please don't forget the integral symbol. Okay. So find the volume if the region enclosed by y is equal to square root of x and y is equal to x squared is rotated about the line y is equal to 2. So y equals 2. That's this line right here. Do you guys agree that the square root of x is this function right here? You guys see that, or is that too light? Is that better? And then do you guys agree that the parabola is the x squared, right? So that right there. So do you guys agree then that the region enclosed, oops, what's happening? There we go. The region enclosed by those two is what I'm coloring in yellow. Talk to me, guys. Okay, the region enclosed by these two functions creates this little space, right? And I'm rotating it about this line. So do you guys agree if I'm spinning it around this line right here, this shape right here, do you see how I have all this empty space? So that's when we need to use the washer method, okay? So this is the only difference between what we learned before break and what we're gonna learn now. We need an R of x, and we need a little r of x. Just like they look like, big R of x is the bigger radius, little r of x is the smaller radius. So if I'm rotating it, do you guys agree that this line right here is parallel to the x-axis? So this is gonna be a dx integral. So if I'm rotating this function right here, this enclosed region, around this line, I'm going to draw a radius from the line I'm rotating around and the x squared. And then I'm going to draw a radius from the line I'm rotating around to the square root function. Which one of those radii is larger, the blue one or the green one? The blue, right? So this is going to be r, and this is going to be little r. Okay. Is everyone cool with that? So in order to now figure out what the equation is, remember, when we would find, so pretend like this square root part is not there. If I'm just focusing on big R, do you guys remember when we'd find area, we would do top function minus bottom function? That's what you're gonna do. Which function is the top function? The line or the parabola? The line. So it's gonna be top minus bottom. So it's gonna be 2 minus x squared. Now I want you guys to write that down because that will help you with your homework. Top minus bottom. And then if I look at the little radius, what's the top function? The line or the square root? The line. So it's going to be 2 minus square root of x. So top minus bottom. Does that make sense? Now, just to kind of show you guys what this is going to look like, if the line was down here, we were rotating around. Don't draw this, just look what I'm doing. And this was big R, and this was little r. Do you guys see how now this would be the top function, and this would be the bottom function? That's the only time that it will switch, is if it's underneath, okay? Okay, so now let's integrate it. So volume is equal to pi times the integral of a to b of big R of x squared minus little r of x squared dx. So what are my bounds? 0 to 1, because the region starts at 0 and it looks like it closes up at 1. Is everyone cool with that? Okay. Now, my r of x, the entire what I wrote in blue, will go inside the brackets. So it's going to be 2 minus x squared minus 2 minus square root of x squared dx. You guys will be happy to know that these type of problems, until you guys get to college, calculator. In college, you guys will have to actually do your thing. And looking ahead at like possible AP questions, it would give you a picture and it'd be like, which of the following integrals represents the volume? And it'll be multiple choice answers that look like this. Okay, so you're not actually solving anything. Sometimes you might. Okay, does anybody have any questions about the setup? Careful, because you guys see how each thing is squared. So make sure you guys don't subtract the functions and then square it, because that's not the same thing. All right, last one. Problem number 2. Find the volume if the region enclosed by y is equal to x squared plus 1 and y is equal to 2x plus 1 is rotated about the line x is equal to negative 1. So here's x is equal to negative 1. Hey guys, what axis is this purple line parallel to? The x-axis or the y-axis? The y-axis. So that means I'm integrating this with respect to y. So this means that everything needs to be dy. So that means that I need to take each equation and get x by itself. So y is equal to x squared plus 1. Subtract 1 from both sides. Square root. Now, if I'm looking at the region that is enclosed, are we comfortable with the fact that this is the region that I'm gonna spin? If I'm looking at the plus or minus, parabolas have a vertex, right? Is this gonna be the positive side or the negative side? Positive side, does that make sense, guys? Because it's to the right of the vertex. So do I really care about the negative here then? No, because the region isn't over here, it's over here. So I'm just going to care about the positive. Okay. For the other equation, I'm going to subtract 1 from both sides. Divide both sides by 2. Are we okay if I leave it like that, guys? Because aren't I just going to plug this in my calculator anyway, so it doesn't matter? No. Okay. Questions on where those came from? Okay, so that's the part that I hate doing. We have that out of the way. Now I need to figure out what is R of X, what's big R, and what's little r. So here's my region. Here's the line I'm spinning it around, okay? I'm not drawing a picture here because, let's be honest, my art is not the best, and I don't want to do that right now. So I'm going to draw a line that goes from this to each function. So from our line to this function, and then from our purple line to this function. So this is going to be big R because it's larger. And then do you guys agree that this will be little r? Because do you guys see how this distance is smaller than that distance? Does that make sense? So before we write it down, this was the parabola, right? But we were integrating, or we were solving it for to get x alone. So this right here is going to be x is equal to the square root of y minus 1. And then the line was x is equal to, what was it? Y minus 1 over 2. Is everybody cool with that idea? Does that make sense? Okay. All right, so here's where we're going to use our brains, and you guys are going to help me out with this. Promise me, you guys, before you guys write your integral, you guys write this step, because this will help you guys to make sure you guys write it correctly. Big R of X. We're spinning it around this line, right? So when we integrated it with respect to y, did we do top minus bottom? What did we do? Right to left. Good. So which function is R? The radical or the line? The radical. Okay. So if I do right minus left, if I do right minus left, do you guys agree it's going to be the radical minus the line? Okay. So it's going to be square root of y minus 1 minus negative 1. So which will be the same thing as plus 1, right? Is everyone cool with that? So then little r of x is going to be y minus 1 over 2 minus negative 1, which is the same thing as plus 1. So right, left, right, left. Questions on where that came from? Are we over this? This is the last volume section. All right, so volume is equal to pi times the integral. If I'm integrating with respect to y, where does this region start on the y-axis? 1. And where does it end? 5. And remember, it's going to be big R minus little r. So it's going to be radical y minus 1 plus 1 squared minus little r y minus 1 over 2 plus 1 squared. And what must that include? dy.